Alright everybody, welcome back. In this video we're going to start working in section 6.9 of AP Calculus, integrating using substitution. This video is going to include examples from the integrating using substitution part 1 lesson. We're going to break integration by substitution down into a few different component parts along the way. So let's introduce you to substitution. First of all, what is integration by substitution? It's a technique that we use to make an integral that is complicated, or that maybe looks complicated, easier to find by replacing a portion of the integral with another variable in such a way that it simplifies the integrand to one that we can easily find using anti-differentiation. Okay? And the main reason why substitution or where substitution is used is in situations where the chain rule was applied in taking the derivative to get to our integrand, and so we need to undo the chain rule, and substitution is a technique for undoing the chain rule. I made it sound really complicated, but it's not as bad as it sounds. Alright, here's our rule for substitution. When we take the integral of something that can be written of the form f of g of x times g prime of x dx, that's equal to the integral of f of u du, where u is equal to g of x. So if u is equal to g of x, that means the derivative of u du is equal to g prime of x. And so in essence, what we're doing is we're taking this g of x right here, and we're replacing it with u, and we're replacing this du, which is the derivative of g of x. Put that right there, and actually I needed my dx there. We're replacing this g prime of x dx with the du. And then this will be something that we can just go ahead and take the antiderivative of. Okay, so in order to get good at this, we're going to try and do as many of these problems as we can. On the first day, I'm going to leave the training wheels on and show you kind of the layout that I use, and leave the training wheels on and tell you what substitutions we're going to actually use, which will make it a little easier for you. Alright. Example 1, we're going to find the integral of 3x squared sine the quantity x cubed plus 5 dx using the substitution u equals x cubed plus 5. And I always write my substitution over to the right-hand side. That's always the first thing that I do. And then I take the derivative of it. And, we're not taking the derivative of it with respect to any variable in particular. We're just taking the derivative and saying, the derivative of u is going to be du. And the derivative of x cubed plus 5, the derivative of x cubed is 3x squared, times the derivative of x, and the derivative of 5, since that's a constant, is 0. And so when u is equal to x cubed plus 5, that means du is equal to 3x squared dx. Now, look at my original problem, and you see that I've got an x cubed plus 5. I'm going to replace that with a u, and I've got a 3x squared dx. I'm going to replace that with a du. The only thing that's left over that doesn't appear in either of those highlighted portions is actually the function sine. And so sine is going to stay here in our integral. I'm going to replace the yellow highlighted portion inside of the sine with a u. And I'm going to replace the green highlighted portion, which is outside of the sine function, with a du. And now I have a function that I can integrate just by finding the antiderivative. The antiderivative of sine of u du is going to be the opposite of cosine of u plus c. So we've taken this integrand that looked really complicated, simplified it, and then found the antiderivative. And now we have only one more step to go, and that is we want to replace our u and bring our x's back into here. And so since u is equal to x cubed plus 5, we're going to put x cubed plus 5 back here inside of the cosine function. And there is our indefinite integral. And if you want to check that, you could take the derivative of this, and indeed, if you take the derivative of this correctly, it should match the original integrand. Alright, example 2. Find the integral of 48x times the quantity 2x squared minus 1 quantity squared dx using the substitution u equals 2x squared minus 1. So u equals 2x squared minus 1 is our substitution. Taking the derivative of that, du is equal to 4x dx. Okay, so looking at this, I've got u is 2x squared minus 1. That's this expression right here, which is being raised to the second power. But what I have here is not quite what I have here. I have 48x dx, but du is only equal to 4x dx. So usually what I have a tendency to do is I ask myself, okay, what can I multiply times du to get this to match the green highlighted expression in my integrand? And the answer in this case is I can multiply that by 12. And so I'm going to replace 48x dx with 12 du. And so this turns into the integral of 12 u squared du. 12 is a constant multiple, so I can just bring that out in front of the integral. And then the antiderivative of u squared is u to the third over 3 plus a constant. Multiplying through, this becomes 4u to the third plus a constant. People go kind of crazy when I start doing this, but 12 times a constant, it's just another constant. If you feel like naming this constant 1 and this constant 2, it doesn't really matter. It's a constant. And then I'm going to bring u back and bring back what u is equal to into my integral. And boom, there's my integral of 48x times the quantity 2x squared minus 1 quantity squared dx. And again, if you wanted to, you could take the derivative of this expression. Oops, I forgot my exponent. You could take the derivative of this expression and it should give you the original integrand. All right. Example 3. Find the integral of sine of x sine of cosine of x dx using the substitution u equals cosine of x. So there's my u. The derivative of u here, the derivative of cosine, is negative sine of x dx, which is almost this. In fact, that's equal to the opposite of du. So I'm going to bring a negative du in. This becomes negative integral of sine of u du. Because this sine has the cosine inside of it, so that ends up becoming a sine of u. And then I take the antiderivative. The antiderivative of negative sine of u du is cosine of u plus a constant. And then we bring u back into our final answer, and this is cosine of the quantity cosine of x plus c. All right, example 4. U equals x cubed plus 4x. The derivative of that is 3x squared dx plus 4 dx, or the quantity 3x squared plus 4 times dx. Look at what I have to replace. Remember, this is my u, and then I want to replace all of this. So how can I get that from this? Well, if I multiply this by 4 du is equal to 12x squared plus 16 times dx. And so I can replace the green highlighted portion with a 4 du, and so this becomes 4 integral of du over u to the third, which is 4 integral of u to the negative 3 du, which is 4 times go up a power, divide by that power. And so this is equal to negative 2 over u squared plus a constant. And then we bring u back. And There's our integral. Okay, I'm going to just keep chugging here. Example 5, find the integral of x squared times the quantity 3 minus 10x cubed raised to the 4th. Using the substitution, u equals 3 minus 10x cubed. So u is this. Taking the derivative, du is equal to negative 30x squared dx. Notice here, I've got my u inside this quantity. Everything else that's left is just x squared dx. So I can actually divide both sides by negative 30, and I get an expression that's equal to that. So this can be rewritten as negative 1/30th integral of u to the 4th du. And then the antiderivative of u to the 4th is u to the 5th over 5 plus c. We'll multiply this out. We've got negative 1 over 150 times u to the 5th plus c. And then we bring u back. And there's my indefinite integral of x squared times the quantity 3 minus 10x cubed raised to the 4th. One last example. Find the integral of x over the square root of 1 minus 4x squared dx using this substitution. U equals 1 minus 4x squared. So du equals negative 8x dx. Again, looking at what we're analyzing here, u is equal to 1 minus 4x squared, so that's the denominator inside the radical. And then everything else that's left is x dx. So I'm going to replace that x dx with a negative 1/8 du. So this becomes negative 1/8 integral of du over the square root of u, which is negative 1/8 times the integral of u to the negative 1/2 du. The antiderivative of this is up a power, divide by that power. So that's negative 1/8 times 2 square root of u plus c. Negative 1/4 square root of u plus c. And then we bring our u back. That's negative 1/4 times the square root of 1 minus 4x squared plus c. All right, that's the end of our first video from integrating using substitution, part 1. Go ahead, try some practice problems on this, and we will continue to build our knowledge and understanding of substitution in future lessons on integrating using substitution. All right, see you everybody. Have a good rest of your day, and enjoy yourself. Bye-bye.